to chip in. So where did this all start? So I was quite excited when I discovered this programmable banking thing, and immediately kind of looked at it from the perspective of what the business I work for does, and noticed that I couldn't do what I wanted. So I chipped Ben, and Ben chipped me back, and one thing led to another, and he said, well, build something that checks the API every few minutes for a new transaction, and then do something useful with it. And so with that taunt, this is where that came from. And we'll look at why the why of that in a second. We'll also look at the how we do it, and a couple other things around the edges. So firstly, perhaps who am I? Name's Renen. I come out of I run a business called SaaS Solutions, and I come out of Knowledge Tree, AFB, and Jumo more recently, which some of you may have heard of. I'm functionally a software developer, mostly databases and Ruby and things like that. And most of our work is in East Africa. We help organizations. It's not so much a punt about for SaaS as it's just kind of considering the context of why this whole kind of functionality matters to us. So SaaS enables organizations to build or to digitize their financial processes, usually in a mobile money ecosystem context. So most of our work's done in, as I said, in Tanzania and places like that, based on USSD, based on mobile money, based on fun things like that. We do a bit of work here, but there's less mobile money here, so there's less work for us here. But really, a lot of what we do deals with getting cash in and getting cash out again. So that's so you can immediately see why this whole Investec Programmable Banking thing is exciting. It allows us to kind of manage bank accounts in ways that are quite similar to the way you can manage a mobile money wallet. So yeah, typically in this country, for example, we use we get money in via Payat at the moment. In Tanzania and Kenya, we get money in and out using Pesa and Airtel and things like that. Some of the banks, but really, what we're all about at our core is managing cash flowing in and out. So this Investec Programmable Banking thing I spotted an opportunity to deal with cash in, but of course, the programmable API doesn't actually allow you to do that. So what I set out to do here was to create a little poller that smacks Investec every minute, downloads any new transactions, and then triggers some activity based on what it finds. So that's effectively the model that I elected to follow. So I guess at the outset I should say that SaaS is completely, in fact, all the projects that I work on are almost entirely built on Amazon. So we're thoroughly committed to that ecosystem already. So for us, building a Lambda or two is quite a natural extension of what we do. Most of what we do is actually still old school, built in Ruby and Rails, running on EC2 scalable instances. But we're starting to experiment increasingly with Lambda functions and the like. And I suspect you can hear my wife killing my children in the background. So apologies for that. My very clever noise cancelling headphones means I can't hear them, but I think you probably can. Okay, so while they kill each other in the corner. So the model that we use, we're going to use an AWS cron job mechanism to kind of trigger this functionality every minute. It's going to run a Lambda function. A Lambda function, for those of you who don't know, is just a sort of a bit like a stored procedure or a chunk of code that runs in Amazon's kind of managed code environment. That little function is going to, in fact, dwell on the function part of that name, not the Lambda part. So really, it's a function, and it's going to pull all the transactions or recent transactions down from Investec, and then it's going to push them into DynamoDB. Why that's useful for us is DynamoDB has much like a database has got triggers. You can use triggers on DynamoDB to kick off other Lambda functions. So once we're inserting new transactions consistently into into DynamoDB, we can then hook Lambda functions onto that to do whatever we want. So the problem is once you push the data into that DynamoDB thing, which is just a database, you've effectively solved the problem, because it can then trigger whatever you want, launch the space rockets, take over the world, based on kind of the actions that fire from that database table. Typically, what we do is in fact push that event that comes out of DynamoDB into an Amazon SNS queue. That's simply simple notification services. It's really just a pub/sub mechanism. We're not going to go there. In fact, we're going to stop at the DynamoDB thing. I'll show you how you can activate those other kind of last steps. But frankly, if we get those first 3 blocks right, we've cracked this problem. So any questions? Nope. Okay, good. Usually with an audience, you can see people and eyeball them, and you can understand whether they're watching or not. So at the moment, I've got 2 of you, which is and 1 space rocket. Okay, so the methodology, just to go a little bit more, just to cut to the chase, and if we drill into that Lambda function in slightly more detail, like to actually kind of like interrogate how do we make this happen. The first thing we're going to do is, at a very high level, is we're going to get all the code, get all the transactions from Investec, and then once we've got that list of transactions, for each transaction, we're going to calculate an MD5 checksum effectively, just a little hash. And then we're going to use that to uniquely identify these transactions to DynamoDB. So we'll use that as our key. And DynamoDB has a conditional push mechanism so that if the key is there already, it doesn't update, which is, in effect, solving the problem for us. So the get was probably the trickier part of this for me, because I didn't know the Investec programmable API particularly well. That's really a case of getting an access token, getting a list of accounts, finding the account we care about, and then downloading all the transactions. So that's really the kind of methodology. And again, if there's any questions or any uncertainty, just kind of, I don't know, wave at me or something like that. I have shared the repo that this code is sitting in the message chats. So if you want to open that up in the interim, go for it. I'll keep talking, and we'll come to the code in a second or so. But feel free to open that up so that you can see it more easily. So casually saying, let's just build an AWS Lambda function and push it to the cloud in Ruby is actually a satanic undertaking. Adam, sorry, did I see you gesticulating?
Yes. Sorry, did you say that you put it in the group chat?
Yes, I tried to.
Maybe I joined a bit too late for it or something?
The Zoom chat. So it should be in the Zoom chat.
Is it?
If somebody could repeat that would be great. I want to take a look.
Yes, there you go.
Okay, cool. Thanks. Appreciate that.
No problem.
Hugs. How do I pronounce your name? Is it Hugs?
Yeah, that works. There you go.
Good. Easy enough. Okay, cool.
Doesn't get easier than that.
Good. Okay, so back to this undertaking. So to build a Lambda function, you could do it reasonably easily through the Amazon kind of console. But as soon as you try and deviate from, you haven't got it yet, Adam. Doesn't matter. I will.
Oh, no, I have it. I was just responding involuntarily to your last comment about doing it through the Amazon console.
Okay, you can just simply do that. It's quite a convenient, quick way of doing things, and actually, it's a contained problem, but it kind of channels you into Node, which is, I have some reservations about it, and it's limited, like as Adam says or indicated, like there's clear problems it's not sustainable. So the way that we're doing it at the moment, which leaves a lot to be desired, is we use a thing called SAM, AWS SAM. Getting it installed is a bastard. So if you're running a Mac, you're in business. If you're running Windows, well, you're probably out of the game anyway if you're running Windows. So let's just ignore you. And if you're running Ubuntu, well, it's not trivial. There's quite a lot of uncertainty around it, but once you get it installed, it does become quite a lot easier. You literally type SAM and it creates a Hello World application for you, which you can then bastardize into whatever sort of shape you want. You can then deploy that by typing SAM deploy. and in fact, once I got to that point, I then added the other kind of functionality around the edges. First, I added a cron to make sure that it ran regularly. Then I added the HTTP code, and finally, I pushed it to DynamoDB. So that was kind of the process that I followed. I must be a bit careful. So if you have to build Lambdas, and Lambdas are great once you get in there, SAM is probably the way to go. Adam, do you have another way of doing it? No. Yeah.
Yes, I do. Sam is the devil. So I'm actually posting in the chat now for everyone. I was fortunate to get a heads up from one of my coworkers who is our cloud expert. And I looked at SAM and CDK at the same time. CDK is phenomenal. There is no reason to do Amazon any other way at this point.
Okay,
and in
so that's
fact,
the new one, if I understand correctly.
Yeah, and that link that I've sent you is to my own repo, which is kind of a quick start guide to using CDK, because the documentation for Amazon's everything is all over the place. But CDK has now come out with an extension where it synthesizes to Terraform. So you can use it for not just AWS, but any of the platforms. Right. And it's a completely different way of doing it. So I warmly recommend checking that out before continuing cloud development.
It's probably right. I almost cried when I Googled something yesterday and found CDK, because it's a new way to do something else. And with Amazon, that just means more pain. Anyway, so there's the repo. And whatever CDK does, the core of this will not really change. So what's going to change is the first and second steps, and perhaps how you provision the cron job. But frankly, the guts of this problem will not, the actual code, this stuff won't change particularly, because that still sits inside your Lambda. What will change is the pain that you have to go through to get the Lambda up and running. Hopefully you've all found your way into the repo, such as it is. There are two files in there that matter. There's template.yaml, which we'll look at in a second, or you can look at it already, and there's app.rb. So having done that, let's quickly take a look. I'm going to try and share. No, I was going to try and share another screen, but that's probably too advanced. How do I get out of this thing? So if I kick through to, I'm going to kick into the repo, make it big. Can you all still see my screen? Somebody can nod. Adam nods. Great. Thanks, Adam.
Yeah.
Yeah. Good. So if I go into here, most of the stuff is generated by our friends at Amazon. And if you go look at template.yaml, this is the bit of code that actually generates provisions infrastructure, or provisions the resources that we're going to use. So that's the one, and I've kept it quite simple. It's not perfect. There's a couple of issues with it, which we'll touch on in a second. But hopefully it's simple enough that it can be digested by you in a reasonably short amount of time. These things can get kind of nasty. So the first thing that you'll notice, or Adam might notice, is that the timeout is at 15 seconds. So the Investec APIs are not particularly speedy. So these things typically run for 3-4 seconds at a shot. So hence the need to up that. But we created a database, the DynamoDB table. That's the resources that we're provisioning. We create a function, and which is a Ruby function. So here's the function, and here's the kind of stuff that's kind of defines how it's going to work. Tells us where to find it, what code, what language it is, and I've created some environment variables here. So this is pretty suboptimal, because in a public repo you don't want your details floating around. What you need to do is move these into Amazon's configuration mechanisms. I've included a snippet of code in the deck, which will show you roughly how to do that. But for the purposes of the demo, for the purposes of getting my proof of concept up and running, I just slammed the credentials right into the file there, like that. And the last thing is to create a cron schedule. So it's going to fire every minute. So look through this file. It's kind of should help you understand, roughly how how the resources are provisioned. What you do with, I mentioned already that you type SAM and init to create the initial hello world function. Once you've created your code, you then say SAM deploy, and it pushes the stuff up. We'll do that in a moment as well, I hope. So that's the one bit of code. The other bit of code, which is worth touching on for a second, the real guts of this is our, I'm hoping I'm going to find it in here, is our app.rb file. And it's, for those of you who don't speak Ruby, there's not that much to it. It's a series of downloads, a series of 8 GET requests to get the various, to make the various API calls, followed by each transaction being pushed to DynamoDB. You can see here I'm reading my environment variables out of that get set for me by the resource creation script. So that's how you get the code in here. I'm cheating. And actually, I don't know how big a cheat it is, but so I've taken the table name that was provisioned and stuck it in here. And the handler effectively get all the transactions for this Investec account, or using those environment variables, and then push them to DynamoDB. So to start at the end, all we do is we turn the transaction into JSON. We created an MD5 checksum for it, and we push that to DynamoDB with a conditional expression saying attribute not exist. So that prevents it re-adding. So that then, so that means if we get a new one, we can then fire transactions on top of that. The rest of the code is fairly mundane, literally making requests to the Investec API, cycling down the data and really, parsing it out. So really not rocket science. And in fact, all I did was I took the there's a Postman library or Postman collection that Ben shared with me, and I really had Postman generate that code for me. So it's relatively mindless, but ultimately it gets a list of transactions down, which you can then process through the system. I think that's the key stuff there. Are there any questions? There's plenty bad about that as well, so there's plenty of scope to criticize it. It's really it is a proof of concept for us. It's not quite production ready, although it's not too far from it either. Okay, so since Adam has remained silent, thanks Adam. Let's do 2 more things before I wrap up. One, I'll just show you how it's deployed, because I think it is quite fascinating for those of you who haven't done it before to see how you can deploy a whole crap load of infrastructure in one line. And then we'll have a look at it actually running in AWS. And in fact, there's some problems there, so we might look at those as well. So how do I share a different screen? I want to share that one, like that. Okay, hopefully you can all see an Ubuntu monitor. Let's just clear that. Yep. So, okay, good. So the 2 commands that matter, the first one is SAM build, which just takes everything in our template, takes everything in our code and bundles it up so that it can get deployed. So really, there's 3 commands: SAM init, then you modify your code, SAM build, it does its build thing, and once it's done that, you can tell it to, if it's successful, you can tell it to deploy it to the cloud. It's really, asks you a few questions where you want to put it, asks for to confirm things, and off it goes. And that is quite awesome. And the fact that it'll be up and running and live now is, in fact, there's no changes to deploy, but it's for me, that's really compelling. Kind of gets the development cycle happening nice and quickly, which matters a lot to my workflows anyway. Okay, so let's have a look at this thing running in AWS. So the first thing is I deployed it earlier. hope you can see that. Let me make it a little bit bigger. And it promptly succeeded, and I thought I was done, and then it failed subsequently. But actually, it was working. When I did this demo 2 weeks ago, the whole thing did work. So I don't think it's too complicated. I think it's a permissions problem or something along those lines. We'll look at that in a second. You can see that it's running relatively slowly, about 3 seconds a cycle, and most of that time is interacting with the Investec APIs. The code, so this is the part of the equation that you can actually review the code, and despite Adam's comments, you can actually do useful stuff in here. It does break your workflow a bit because this is not quite as easy to get into the Git repo, but the code is there. If we then, so that's the Lambda. So there's our code. As I said, you can see that it's failing.
Just to be clear,
yeah,
all in favor with trial and error and fiddling around with the Lambda code live until you get it working, but it has to be checked in with the code base.
Yep, otherwise the world ends when things go wrong. So if we kick across to the DynamoDB database, if I go look at tables, I can find in this list of play tables, the Investec Polar table. And if we're lucky, yeah, there's all our transactions sitting there. So this is neatly pulling the stuff down. I had it running every minute for a while and stopped it. Started it again about half an hour ago, but it does what it's supposed to do. The next step in the journey to kind of fire off subsequent Lambda functions is simply a case of going into more triggers and adding either an existing or a you can create a new Lambda, or you can link it to an existing Lambda function, and that allows you to take over the world. So once you're getting events out of the DynamoDB system, you can do whatever you want, and it's pretty cost effective. So from where we stand, or from where I stand, I'm happy that kind of this is something we can build on. It's certainly something we can work with. I suspect that if we punted it too hard, the Investec guys would become a little uptight with us kind of polling every minute. So we'd probably dial it back a little and kind of do it every 10 minutes or so, or every 15 minutes. But the downside for us, the downside on that is if somebody makes a payment or purchases an insurance policy or something like that, you really want to kind of message them pretty quickly after the transaction's happened to confirm that it's happened. So the downside on slowing it down is that you make your customers less happy. But yeah, I hope that the Investec guys notice and actually provide these APIs and these callbacks more intelligently in due course, because they are running on Amazon after all. They should be able to create callback mechanisms reasonably straightforwardly. It's worth probably touching on that Lambda a little bit more. For those of you not familiar with it, it's worth, where have we gone to there right underneath me. So in terms of diagnosing what's going on, Amazon provide you with so it's failing, like why. So if we go and look at our logs there, which is another one of Amazon's really clear-cut, unambiguous, simple solutions. We can go see what's going on, and we can see that it is complaining that the conditional request failed and where it failed. Line 17. So I'm not sure why it's failing. I'll have to go and debug that. A bit surprised, but anyway, so that's the way real code goes. So we could cut into our code and we can go figure that out. But I think that's I don't know how much we'll benefit from doing that right now, and it might take a while. So yeah, that's me, I think. Did I have anything else to say? I don't think so. We've looked at most of those. What remains to do when I did this talk initially, I needed to publish a repo. I was quite uncomfortable with having my Investec identity strapped into a public repo. So I wanted to get the code into secrets. So this little snippet here is the clue you really need to be able to do that, which drops into the code, drops into the resource template, creating the policy to allow you to kind of access and store a client ID or whatever, a piece of configuration data inside of Amazon's configuration store. The name jumps out of my head, but that works pretty easily, and then you can read that in your code. And finally, the fudge that I did, I had to create the table permissions manually, and I've got some work to do on that. It's not right. I should be able to provision the table correctly through the code, and it's not doing that at this time. Just to be very clear, this code here in our template on YAML, this provisioning of the DynamoDB table, there's two problems. One is I'm not getting the name to use in the code. You saw that I'd hard-coded that in there. And secondly, this policy, DynamoDB CRUD policy, which should give me access to that table, this reference, I think, is not working correctly. I need to fix that. So those are kind of the key things that remain to be done here. But that can be hacked if one needs to get something just up and running for one account. If you try to do it generically or sustainably, well, then you'll need to solve those. But it's certainly in the tractable space, which probably means 2 or 3 days of hard struggle with Amazon. Anyway, so that's me done. I hope you found it interesting. And are there any questions?
Cool. Thanks, Renen. That was very informative and nice and detailed. Thanks for all the effort. So what are your next steps?
Let's do Adam first, and then we'll go there. Adam.
Okay. Cool.
So mine's not so much a question, but just a hats off for persevering with Sam. Because the fact that you managed to get this up and running with it is quite an achievement. I'm actually really excited to see how you interact with CDK, which you can use multiple languages, not just JavaScript. Because what you're describing right now, the last thing that you said about getting the permissions right and all that kind of stuff, is all taken care of for free by Amazon. They've really done a good job.
Sam's spec actually says that they don't do that. Well, not so much don't take care of the permissions. I'm sure we can solve that. But getting the name of the table into your code.
Everything. And Sam, by design, is incompatible with CDK. But as you said, you can literally take your lambdas, shove them in somewhere else, and they'll work fine. So you won't have lost any of your functional code. You won't have lost any time as far as that's concerned.
If you've done any work with Amazon, you'll know the functional code is never the problem. It's trying to work out which bloody arcane piece of incantation you need to chant when to get the stuff to work.
Exactly. But this is I'm so excited for you, because you're going to be jumping from SAM to CDK, and it's just a whole other experience.
I may never go there because I've got this to work. It's all balancing neatly at this point. So, but I'll check it out. I'll definitely take that on board. Vink. Or Vinci, did you want to interject? I hope you're an Amazon employee listening loudly.
Dear Lordy, I would kill myself. No, I was going to ask, how quickly and effectively does this build if you include more gems and similar? Like, how scalable is this with libraries? Does that really matter, or
yes, it matters.
Not really
So let's put this in perspective. So with mediocre degree of understanding of the whole SAM serverless space, this took me 3 hours probably to put together end to end. So it's not, so that's the first kind of part of that answer. Not that you asked directly, but it is a tractable, solvable problem once you kind of got the SAM stuff down. And if you're happy to kind of deal with a few compromises. So your question, though, the other half of the question is like, what is, if you start loading this thing up with gems and stuff like that, what are the consequences? I don't know if it gives it to me here. No, let's look over here. fact, it should give it to me here. So if I look here, you can see. Are you still there? Can you hear me?
Yep, I can hear you just fine.
Got audio?
Yeah, I can hear you.
Yeah, you're clear.
It would appear that I might not be.
No, you're clear as well.
I think I lost the audio for a second there. Sorry. I'm back, I hope. So this bit of this here, we can make it much bigger. This matters. No, where's it gone? So the build duration, that's how long it takes to run. So in fact, this took 1.2 seconds, and they billed us for 1,300 seconds. They rounded up to the next 100 milliseconds. So your execution time matters, and your memory size matters. And it matters in two ways. One, it matters in terms of the startup time. So the bigger the slug, the bigger amount of code you've got to get loaded. Things just slow down. It's not ideal, and it matters. I can't remember what the other way is, but so adding loads and loads of gems, it really comes down to billing.
They charge you more.
They charge you more, and your code, everything is slower. So basically, you want to keep things as tight and tidy as possible. But they do provide you with some tools to kind of manage that. So they've got things called layers, which you can use to kind of simplify your code, not necessarily the size. And you can keep things quite tidy. So we use the stuff as sort of salt. We use it as connectors. So we've got a Rails application running, which we use for the user interfaces. And we've got a lot of the kind of ingestion of data in our case, gets done through Lambda, stuff which doesn't have user interfaces. And there our need for libraries is relatively small. You need JSON, you need HTTP, you need a couple of other things. And that's mostly, this has got JSON and HTTP, and that's a large part of what you're trying to, what we need to do anyway. And you can see that its max memory used is 81 megs. I think the slug size on this was 4.5 megs or somewhere thereabouts. So no, not too dramatic. So yes, you don't want to go completely bananas, but frankly, in any code, you want to keep it quite tight. You don't want to have too much stuff scuttling around. The other problem with dependencies is that, for example, in this case, no, not in this case. If you use, for example, the MySQL gem, it uses libraries that are not installed in Amazon's environment. So you actually have to then create a Docker function or Docker image and build this thing in a Docker image and then deploy using some weird incantations which relates to the Docker image. And that just adds complexity to your world and more pain. So, but again, once you've figured these things out, it becomes less painful. So the problem with gems is much more the configuration than it is. That's what you're really going to watch for. I don't know if that answers your question.
Yeah, no, that completely answers it. Sorry, I asked because I'm from a very firmly traditional Rails-ish background. So these super lean environments are fascinating to me.
So what I can't answer, what I can't speak to is what happens when you have, 50 Lambdas drifting around, how you structure your code. We haven't answered that yet. We've got, 5 applications, 20 or 30 Lambdas drifting around. So at the moment, it's still tractable. When we get to thousands, it'll obviously be a different story. I don't know if anybody else has got answers to how it's, well, maybe that's beyond the scope of this though. So, any other questions?
What's your next steps? Where are you taking this next, or are you taking it anywhere? Or?
So it's really nice to have it in our back. No, it matters. So we've got it in our back pocket. We have, I think at this point, 3 clients in South Africa. And having this here means that we've got another trick up our sleeves. As I said at the beginning, a lot of what we do deals with getting cash in and getting cash out. Obviously there's more to it than that. It's really about managing customers in that context. But frankly, being able to get cash in this way is helpful. Pay@, which is the solution we're using at the moment, is antiquated. It leaves a lot to be desired. It works well for taking deposits in at supermarkets and things like that, pep stores and the like. But if you want to, for other parts of the market, this is really compelling. And so our next step is to kind of find a customer who actually will leverage it, and to build some real production kind of functionality around it.
Yeah, I guess you kind of touched on the interesting stuff, which is the SAM stuff. Cool.
I think the audience would do well to listen to Adam's comments on CDK there, because I think there has to be a better way.
Yeah. CDK is a much better way. I don't know if anyone else has any questions, comments, use cases potentially for this. No. Okay.
So where it's useful beyond, so at the moment the APIs deal well with credit cards. This allows you to get beyond credit cards, which is extremely useful. So I haven't tested how fast the transactions actually arrive in there. Seems to be reasonably quick. So
the other thing I could see this being very useful for is certain types of small businesses that basically have a flow system that relies on EFTs and money being paid into an account to verify your order, and then they, based on that,
that's exactly what we do. That sort of thing.
We actually have a couple of clients who rely on similar things, and it's a bloody nightmare to handle that by hand, where you have some business developer or some poor sad admin clerk sitting there with a page open and checking it once every hour to see whose orders are now confirmed, so that they can send them an email and proceed with the rest of the order. And this potentially allows you to automate that entire process.
Yeah, so what you described doesn't scale very well. In fact, it doesn't normally scale much beyond Tuesday. So
no.
So exactly, the reason for this code is to be able to take that admin clerk out of the equation. That's precisely why it matters to us. Good. Well, thank you all for listening. Really appreciate it.
Cool. Thank you. Thank you for a great demo. It was very informative from all perspectives. Thank you.
Pleasure. I will let you know how it goes to CDK.
Cool. Cool. Do you want to stop sharing for a second?
Stop sharing.
Cool. Let me get my sharing going one more time. Cool. Hackathon. So everyone's registered, yes?
No, but I am sorting out my team as we speak.
Okay, yeah, please register, get your teams sorted out. As Ben's mentioned before, if you don't have a team or just have a need to be part of the hackathon, then register as an individual, and there'll be some mechanism to sort out teams as people register. So please, whatever it is, however you need to join, please register and be part of it. The more people, the more ideas, the more awesome stuff. Yeah, it'll just keep building the community and build interest in the community, and hopefully get some production type stuff out there and later. So please register as soon as you can. Let's see what we can build. Other than that, I don't think we have anyone from Investec here. So I think that's a wrap, guys. Thanks for joining, everybody. Thanks for being here with me here and seeing it through. I appreciate everyone joining and all the comments and participation. It's been great.
Don't worry, Hugs. You're at least as pretty as Ben is.
Yeah, I know. And if I let my hair grow as long as his, I might be prettier, right?
Probably, eh?
Yeah. And I've got a better name, right? Come on.
Definitely.
That does win. Yeah.
I mean, you definitely have a cuddlier name.
Exactly. And that's, I mean, don't we all need extra cuddles in this world? You know, wouldn't the world be better with more cuddles in it?
I'll tell that to my wife. Righty.
Okay.
Cheers all.
Cheers,
See you.
guys.
Cheers, everyone. Yeah.
Guys.
Have a lovely
everyone.
evening.
You too.
Bye.
Cheers, Adam.